Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science, Jesus and Mary College, University of Delhi. So friends, we are looking at Python programming in this particular series, and we are talking about how we can write complete programs using the various elements and the various constructs which are provided to us by the Python programming language. So in the previous lecture, we were talking about how literals can be used, how identifiers are declared, what are the different types of operators which are provided to us by Python, and how expressions can be used and evaluated in the Python language. Now in this part of the lecture, we are going to talk about how user input can be taken, what are the commands to give output to the user, and what are the different kinds of control statements which the Python language provides to us. And we will also look at some of the errors which may come into your code while you are writing, right. So, quickly beginning with the first part of the lecture, that is the input statements, right. So, we all know when we need to take input from the user continuously, and for this in Python there is an inbuilt function called the input function. So, you will use an identifier, like for example, you use an identifier name, and in that you will use the input function, and in the parenthesis you will write the message which you want to show to the user. So, whatever value the user will enter, that will be saved in the identifier or in the variable name, and that can be printed. So, this is a simple function called the input function. Now, if you want to display the output to the user, the function that you will use is the print function. Again, within the parenthesis, whatever you will put will go into the onto the screen, will be printed onto the screen, right. And we can always add the a variable, or we can add certain identifiers in the print statement also. So, whatever you put in the quote will be added as, will be shown as it is, and then you can insert the identifier in between that. So, these are the two statements which are commonly used. One is the input statement using the input function, and the output statement is the print statement, right. Then we have conditional statements. Now, there are many occasions in programming where you need to take action based on certain conditions, right. So, like other programming language, Python also provides us with conditional statements. Of course, you have the if statement, but here you will use the if, elif and the else statement, right. So, this is a different variation of the if else statement. Here we use the if statement, the elif and the else statement. So, first you will write, say for example, in this code we are writing, if age is less than 18, you do some action. If there is in between there is, say, elif age is equal to 18, you do something, and the last statement will be the else statement. So, in this what is happening is that you have the if statement is the beginning of the conditional statement, the else statement is the terminating statement, and in between the if and the else you will have the elif statements. So, the elif statements are going to be there. Also, it is important to note that the if, elif and the else statement, they always terminate in a colon. So, you always terminate them with a colon sign. So, the syntax has to be appropriately used. Then after the conditional statements, there is another category of statements which are very, very important, that is the iterative statements or the loop statements. So, if you want that a particular set of statements need to be executed for a given number of times, then you will use the loop control statements, or which are also known as the iterative statements. So, these statements are very important because we had discussed that Python provides us with a lot of sequence data types, like it provides us with lists, tuples, dictionaries, sets, strings, etc. So, when you want to access individual elements of these composite data types, then also loop statements play a very important role. So, there are two main types of loop statements that we look at. First is the for loop, and then is the while loop. So, in the for loop basically the syntax is again similar to what is used in the other programming language, but we take an example of a composite data type. Like for example, if we have a list called fruits, okay, and in that we have 3 fruits are defined. Now, if you want to access all the elements, so how you will use that? So, you will use for fruit in fruits and you will print the variable fruits, right. So, what we are doing is that through this we are accessing the individual elements within the list which is given to us, right. You can also use the simple for loop, like for that we have been using in other programming languages for repeating the statements also. That is the same loop that you are using for I in, and you can use it that way also. But this is particularly interesting because by this construct you can access the composite elements within the composite data type. Then we have the while loop. Say for example, you want to print the numbers, okay. So, what you are going to do, you define the count, you define an identifier count, and in the while statement you give a condition. So, your while statement is always followed by a condition and then a colon sign, and then you give the statements. So, it is very important to note here that unlike other languages, we do not have the curly braces here to define the scope of the statement. So, generally you use the indentation method to show that what is the scope of the loop, where the loop is starting and where the loop is ending. So, when you have a slightly indented group of statements, that mean that all those statements are part of the loop. So, therefore, in Python indentation plays a very important role in controlling the flow of the program execution. Then we also have the break statement, which is used to exit a loop prematurely, right. So, if you want to break or if you want to come out of the loop, then you will use the break statement. So, if you have a for loop, say you write for I in range and you give that range, okay, and then there is a condition is specified, and if that condition is true, you want to break out of the loop, then you will simply write the break. Again, as I said, that there are no brackets or there are no braces which are used, it is only the indentation which is used for specifying or which is used for defining the scope of the loop or of the iterative statements, right. Then we have the continue statement, like the break statement is used to break out of the loop prematurely. If you want to skip the current iteration but continue with the next iteration, there you will use the continue statement, right. So, if you want that after this iteration should be stopped, but the next should continue, you will use a continue statement. Like in this example we see for I in range 10, and then you are comparing the value of I, you are using the modulo operator. So, you write I modulo 2 is equal to 0, that is if the number is an even number, then you want to go to the next iteration, okay, and in the end you will print the value of I, right. So, here what you are doing, you are actually going and printing the odd numbers, because you are not printing the even number, you simply continue if the remainder comes to 0, right. Then in Python we also have another statement which we call as the pass statement, right. Now, the pass statement is basically used as a null statement, that is it basically does nothing, right. So, when you are defining the for loop, so you write for I in range 5, okay. In this example we are looking at this example, and we say if I is equal to 3, then you say pass, that is the loop does not do anything if the value of I is equal to 3. So, whenever the value of I will become 3, it will pass, otherwise it will keep on printing the value of I. So, here the values which will be printed will be from the first value of I till 5, but the value 3 will not be printed, because when it comes to 3, the loop will not do anything, it will simply go back to its iteration, right. So, we have seen that Python provides us with input output statements, right. So, the input function is used for inputting the data, the print function is used for displaying the output to the user. Then we have the conditional statements, which are the if, elif and the else statements. So, these statements are used for making decision. When there are multiple courses of action, you will use these statements for taking a decision. Then when you want to have an iterative flow of program control, that is when you want the loop kind of a structure to run, or you want to execute the same statements a number of times till the condition is not met, then you will use the for and the while loop for that kind of statement. And then we also have some special statements which are like to break out of the loop, you will use the break statement. To continue to or skip to the next iteration, you will use the continue statement. And just to have a placeholder, or just to allow the loop not to do anything if a particular condition is met, then you will use the pass statement. So, these important statements, these are all statements are known as the control flow statements, because you can control the flow of program execution by using this kind of constructs. Now, we understand, or we have come to a point where we can write simple Python codes, and using the constructs and using the concepts that we have done, that is we have talked about identifiers, literals, operators, expressions, how you can take input from the user, how you can give an output to the user, and how you can control the flow of program execution. So, once the programmer starts using these constructs to build the program, the next challenge which is forced or which is posed before a programmer is error handling, because we know that once you write the program, you are bound to have some errors in your code, right. So, it is very important to systematically understand what are the different types of errors which can come in your Python code, and how each of these errors can be resolved. That is what should be the strategy to resolve these errors. So, basically in any program that you are writing, there will be three types of errors which you can see. The first type of error is the syntax error, that is the error is in the code's syntax, right. Say for example, if you are violating the norms of declaring the identifier. So, we had seen that the identifier or a variable name or a function name cannot begin with a number, but if you do that, then that will result into something like a syntax error. Then there will be some runtime errors, that is the errors that will occur during execution, right. And then the third category of errors, which is the trickiest to solve, will be the errors which are which will not be shown while the program is executing, but they will show incorrect results. So, syntactically the program may appear correct, the program will also run properly, but it will not give you the right or the desired output. So, that kind of errors are known as the logical errors. So, let us look at each of these errors separately. Say for example, of a syntax error, right. So, in this statement, if you see, we are writing if x is greater than 10, and you write print some statement, right. Now, we have seen that in the syntax of the if statement, it is always ending with a colon sign, right, but here the colon sign has been missed, right. So, this statement is going to give you a syntax error because a colon sign is missing after the if statement. It is simple as that, right. Or say, just as I just said, if you are using some special character, or if you have used a hyphen in declaring your identifier, in declaring a variable name. Say for example, you write my dash name is equal to, you define a string like that. So, that is again going to give you a syntax error. Why? Because again there it is violating the syntactical rules of the language, or you forget to put a colon, or you forget to put a semicolon. So, all these things are going to give in the syntax errors, but syntax errors are the easiest of all errors to find and to resolve, because they are very direct kind of errors. The second category of errors that we see are called the runtime errors. So, these runtime errors can be something like you divide by 0, right. So, it is actually an exception which is taking place, right. So, this is a fault in in writing the correct expression. So, that is going to result into a runtime error. Or if you are trying to access a file which is not available, which is not present, right. So, then also it will give you a runtime error like file not found, because you are accessing a file which was not located, which was not being Python was not able to locate that file. So, this type of errors will give you the runtime error message. Again, these errors are easier, they are slightly more trickier than your syntactical errors, but still they are easy to locate and they are easy to resolve. The third category of errors that we see are the logical errors. Now, logical errors, or in Python or any other programming language, are the mistakes in the code that produce incorrect results or unexpected behavior. So, the code will run without any syntax errors, you will not see any syntax errors, but it will not give you, the code will not give you the expected outcome or the expected result, right. So, there could be many situations where logical errors could be seen, or why a normal, the correct or the expected outcome is not being shown to us, right. For example, the first category of logical error is off by one error. Now, what is off by one error if you see? So, here what we are seeing is, we are seeing a simple loop, right, where we are declaring a variable total is 0 and then we run for I in the range 0 to 5, right. So, if you want to print the numbers, right, if you want to have the 5 iterations, then it should start from 1, right. Your range should start from 1, only then it will give you the total of 15 and it will not give you a total of 10. Why? Because here it is declaring the range from the, it is declaring a wrong range. Instead of 1 to 5, you are declaring a range from 0 to 5, right. So, therefore, this type of error, this is syntactically the program is correct, the output should be 15, but here the output of the program will be 10. So, the programmer has to find out where exactly the mistake has occurred, right. Then another very common area where logical errors may creep in is when programmers tend to misunderstand the Boolean logic, right. Say for example, if you want to check whether a number is between 10 and 20, okay, and you have a number which is say 15, right. So, you write if number is greater than 10 or number is less than 20, right. But we actually what we need to write is, we need to write and, right. So, instead of or, the logic is and logic, okay. Why? Because you need to check both the conditions have to be true, that is the number should be greater than 10 and it should be less than 20, only then you will find it. Otherwise, what will happen, that if you are putting or, then if you declare a number say 21, so 21 will be greater than 10 and it will be evaluated to true. So, if either of these is true, it will still give you a result as true. So, even if your number is 21, it will give you the value as true, right. So, therefore, the output in the range, that is which is the logic of the statement has to be correct. So, here we are using the OR function or the OR logical operator, whereas the operator which should have been used was the AND operator. Then another point where logical errors can creep in are the incorrect variable initialization. That is, your variables might be initialized with incorrect value or they are not initialized at all, right. So, when you do not initialize, see conventionally we always say that even if the language allows us to use an undeclared variable, the programmer should refrain from doing it. You should always declare your variables before you are using them, right. That the precise reason for that is that it will avoid all kinds of logical error, right. Say for example, here if we initialize, if we have a list, say we have a list of numbers 10, 20, 30 and we initialize the total, okay. We have a value total, we have a variable total which we are initializing, right, and then we run a loop for num in numbers and then we are actually trying to find out the average, right. So, what we are doing is we need to find out the total. Total will be number plus total, total is equal to total plus number and then we calculate the average. So, in this case the wrong initialization has taken place. So, instead of writing total plus is equal to number, we are just writing total is equal to number. So, the initialization operator or the assignment operator which has been used, it should have been, it is actually incorrect in this case, right. Then sometimes when you are working with functions, right. So, functions can also return incorrect values to the user, right. So, that will be a logical error in the function. For example, this is a function that we have declared to check whether a given number is even or not, right. So, the function is actually returning the value. So, we are saying return number %2 is not equal to 0, right, whereas it should have been number is equal to 0. Then you say that print is even 4, right. So, what it is doing is that even if you are putting the number 4, okay, it is still giving an output as false. Why? Because it is not using the correct operator. The value which the function is returning is the incorrect value, because there is a problem in the logic of the comparison operator, right, because we are not using the equal to sign, but we are using the not equal to sign in the logic. So, basically these are errors, what we are trying to see here, that the syntax of the program or the statement is correct and therefore, there is no error which will be pointed out. However, where the result is to be true, you are getting a result as false, right. Then also we are using the wrong data types, right. So, we are performing operations with incorrect data types which can also lead to logical errors, right. For example, if you want to add two integers, but while declaring the integers you are declaring them as strings, right, you are using the quotes to declare. So, in this case if you have declared A and B as two integers, but you put them in strings, then it is not going to add the number, but it is going to concatenate the string instead of adding the number, right. So, instead of getting the answer as 15, you will get the answer as 510, right. This is because you are using the incorrect data type to declare your identifiers, because here the thing is that in Python it will not give you an error that you are using the wrong operator or data type mismatch, because the plus operator can be used for concatenation of strings as well as for addition of numbers. So, therefore, here in Python this kind of logical error is also commonly visible. Now, how to identify and fix the logical errors is also very important. So, you need to ensure that you have a clear understanding of what the outcomes should be. So, before you start writing the code, you must understand the intended logic of the program, and then we can also use some debugging tools, right, which will use print statements or a debugger to trace the values of variables and understand the flow of your program, because if you are not getting the correct value, then at multiple places within the program you will place statements so that you know how the value of the variable is changing, and that may help you trace how where exactly the incorrect assignment is happening, right. And also we can write some tests to validate that the function and methods behave as expected. So, you always need to review and refactor your code regularly, so that it is very clear and it is very correct. So, it does not lead to any kind of logical errors, and which which may become difficult to retrace. So, this was about the common types of errors which may come in a Python program, and how these errors, that is the syntax errors or the runtime errors or the logical errors may be handled. Now, besides errors, there are there are exceptions which may also occur in the program, right. So, there are what are exceptions? Basically, exceptions are sort of like runtime errors which are unexpected error in the program, right. And we should not, the program should not terminate, or the program should not end abruptly without giving an explanation to the user of why the error occurred or why the program failed, right. So, in order to avoid that situation, we have Python provides us with a sophisticated exception handling mechanism, right. So, there are two important features which are used to handle any unexpected error in the Python program and add some debugging capabilities in them. That is, in scenarios where the programmer is anticipating that some kind of exception or some kind of unexpected error may occur, already there is some exception handling code which is in place that would cover that kind of a scenario. Okay. So, what is an exception? Basically, it is an event which occurs during the execution of a program that will disrupt the normal flow of the program's instructions, right. So, basically, like we had seen in the runtime error, like file not found or divide by 0. So, what are these? These are unexpected problems, unexpected error, and they can disrupt the flow of the program, right. So, in general, when a Python script encounters a situation that it cannot cope with, it raises an exception. Okay. So, an exception is basically a Python object that represents an error, right. And whenever the exception is raised, it is always to be handled by the immediately, otherwise it will terminate and it will come out. So, exception handling is very important. Exception handling is Python, in Python is a mechanism to manage errors or unexpected situations which may occur during the execution of a program. So, instead of letting the program crash, you should handle the exceptions more gracefully. So, for this there are three blocks which can be defined. First is the try block, then you have the except block, and you have the else block, right. So, in the try block, basically what we do is we place the code which the programmer thinks may lead to an exception, right. So, it will lead, if the programmer thinks that this particular segment of my program can lead to an exception, he will place that in the try block. Then you have the except block. Okay. So, as we seen, the code which might throw an exception, if no exceptions are raised, then the code within the except block is skipped. Okay. So, try block will throw an exception. If an exception is occurring, then the else block will see it. If no exception is raised, the code within the except block will be skipped. So, except block is the block which catches and handles the exceptions raised in the try block. Okay. So, we can specify the type of exception to catch. If no type is specified, then it will catch all the exceptions which are being raised in the try block, right. So, you can also access the exception object using as to get more details about the error. Okay. So, in the try block, you try whether exception is there or not. In the except block, you put the exception handling code, that if exception is occurring, then it will come in the except block. And in the else block, we will put the if else block will execute if no exception was raised in the try block. Okay. So, it is useful for code that should run only if everything in the try block was successful. So, then you will put in the else block, and then you have the finally block. So, the final block will execute no matter what, regardless of whether an exception was raised or it was not raised. So, this is basically used for cleanup actions. The final block is used for cleanup actions like closing of the file or the resources. So, basically when an exception will occur, it will come to the except block, If an exception is not occurring, it will come to the else block, and then ultimately it will come to the final block. So friends, this was all about exception handling and error handling in Python code. We will talk about more topics, more interesting topics about the Python programming environment in the following lectures. Please keep watching CEC. Thank you.